So we're getting into some pretty deep trigonometry here today, and you probably remember your sine and your cosine and your tangent, and that's great. Well, today, not only are we going to evaluate things like the sine of 30, the sine of 45, or the sine of 60 degrees, but we're going to focus on the exact values as opposed to the approximated values. See, what happens is when you evaluate something like the sine of 60 degrees, you get radical 3 over 2, and that's considered our exact value. Because really, when you try to enter that into your calculator, you end up getting what we call an irrational number, a number whose decimals continue indefinitely. And the moment that you attempt to express this as a decimal value, it's turning into an approximation as opposed to an exact value. Typically engineers, they're building things, they like to be exact, and we can appreciate that for sure. So in this video, we're going to see things like, can we evaluate something like the sine of pi over 4 or the cosecant squared of pi over 3 plus cosine of 3 pi over 2. That's a mouthful, isn't it? So it's going to get pretty deep here today, but we're going to do our best to take it step by step and sort this out nicely. So the first thing you'll notice is we have like our three traditional functions: sine, cosine, and tangent. And remember, trigonometry is this beautiful idea of, okay, we've measured the sides of triangles, we've measured the angles of triangles. Now we're going to kind of bridge those two together and kind of marry those two. And all we're doing is studying ratios. So if we said, okay, the sine of A, we're standing here at angle A, we want to know what is the ratio of the opposite compared to the hypotenuse, okay? And the ratio is the value of sine. Or maybe we said, you know what, let's do cosine, right? So that's the ratio of the adjacent relative to the hypotenuse. Or if, maybe we said, let's do tangent instead. Now we're talking about the ratio of the opposite compared to that adjacent side right here. Now, we're also going to be dealing with these three reciprocal functions, okay? You'll notice this is an abbreviation for cosecant, and all it is taking the sine function and flipping it upside down. So this is the reciprocal of sine. It's hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. So we'll practice those a little bit. So we're focusing on the exact value of some really special angles like 30 degrees, 45 degrees, 60 degrees. And what are their exact values? And we'll use these given triangles as a launching pad to get us going here. So the first thing I actually want to do is I want to convert these angles into their corresponding radians. Just say, okay, so 30 degrees is pi over 6, 45 degrees is pi over 4, and 60 degrees is pi over 3, okay? So let's pretend we're standing up here at the 30-degree mark, right? I'm up here. We'll draw a little stick figure. We're standing up here. So this would be opposite over here. This would be adjacent, and this would be your hypotenuse. So your sine function, opposite over hypotenuse, well, I can't spell HYP, would be 1 over 2. So that's a really nice number, 1 over 2. Cosine would be radical 3 over 2, and tangent would be 1 over radical 3. If we want to rationalize that, it would become radical 3 over 3, and that's the version we'll probably go with. Now, the other thing we might as well cross off our list while we're at it is we'll do our reciprocal function. So the reciprocal of sine is going to be cosecant, and so it's 2 over 1, or just 2. The reciprocal of cosine is going to be secant, so it would be 2 over radical 3. And once you rationalize that, you're going to get 2 radical 3 over 3. And last but not least, the reciprocal of tangent is going to be cotangent. So if I reciprocate this one, I'm just going to get radical 3. I could have reciprocated this one, and then I would have rationalized it, and I would have gotten the same answer, of course. All right, the next one is going to be 45 degrees. So we're going to pretend we could either pick one of two spots, right? We could pretend we're standing right here, or you could go up to the upper left-hand corner. But if I'm standing right here, this is going to be my opposite. This is going to be my adjacent now, and this is going to be my hypotenuse. And so we can walk through those ratios. Sine is going to be 1 over radical 2. Rationalizing that makes radical 2 over 2. Cosine is going to be exactly the same thing, you'll notice. That's pretty interesting. And tangent comes out to be just a 1. That's really cool. Reciprocating these, cosecant is going to be radical 2, secant is going to be radical 2, and the reciprocal of 1 is just 1. So that's really cool. All right, one more to go. Let's pretend we're standing at 60 degrees. And I'm going to do a little erasing here on this one. So we're going to rewrite these bears. Okay, let's find another fun color maybe. Let's go pink, eh? So let's pretend we're standing right here. And now this guy's opposite. This guy's my adjacent now relative to where I'm standing. And here's my hypotenuse still. So opposite is going to be radical 3 over 2. That's going to be our sine function. Radical 3 over 2. Cosine is going to be 1 over 2. And then tangent is going to be radical 3. Oh, just radical 3. Yeah, radical 3 over 1, which makes just radical 3. Okay. Reciprocating these, we're going to eventually get 2 radical 3 over 3. We're going to get 2, and we're going to get radical 3 over 3 once we flip and rationalize it. So I went really fast through the rationalizing. If you have any questions on rationalizing, just throw it in the comment section below, and I'll do my best to try to explain it there, or I can point you in the direction of another video that covers that one more intensively. Okay, now we're going to zoom in and kind of focus our attention on a special group of angles called quadrantal angles. These are angles that fall on an axis, and they don't fall in a specific quadrant. They don't really belong to a quadrant. So what we're going to do here is, let's see. So, okay, we could first convert these to radians. So 0 degrees is 0 radians, 90 is pi over 2, 180 is just pi, 270 is 3 pi over 2, and 360 is going to be just 2 pi. Sweet. Okay, so sine, if you remember something from the unit circle, the sine function, or the value of sine, is always equal to the y-coordinate. So as we go around the horn here, these y-coordinates are going to be your sine values. How sweet is that? So, and we're just going to keep it that simple. So we're going to say, okay, 0, 1, 0, negative 1, back to 0. Okay, similar to that one, cosine is always equivalent to your x-coordinate. So as we go around the horn here, your cosine values are going to be these x-coordinates. It really, really is that simple for today. It really, really is that simple. So if they want the cosine of 0, we'll say 1. Cosine of 90 is 0. Cosine of 180 is negative 1. Cosine of 270 is 0. And the cosine of 360 is back to 1. Now, how do we get tangent, right? Well, here's a nice note for your notebook. The tangent of theta is always the sine of theta divided by cosine of theta. So if I take 0 and I divide it by 1, I get 0. 1 divided by 0 is non-existent, okay? 0 divided by negative 1 makes 0. And then you can see non-existent and again 0. So that was a little anticlimactic, wasn't really exciting. What if I did cosecant and I reciprocated everything in this row? When I say 0, think of 0 over 1. Reciprocating that puts 0 on the bottom, so we're undefined. Reciprocating a 1 is 1, undefined, negative 1, undefined. Secant, so I'm reciprocating this row, is going to be 1, undefined, negative 1, undefined, and positive 1. And then last but not least, we'll reciprocate cotangent. So we've got undefined. This is a funny one. How do you flip that? Well, pretend like it's 1 over 0 for now. So when you flip it, it becomes 0 over 1, which is 0. And then we'll get undefined, 0, undefined. So that's pretty weird. Now, this is a sneak peek, a little ninja trick here. All those undefineds we just wrote, those are going to show up as vertical asymptotes when we graph each of those functions. So you'll notice sine and cosine, they're always defined, so they won't have any vertical asymptotes. But these other 4 functions all have a variety of vertical asymptotes as you graph them. All right. So I think we're finally ready to dive in and actually evaluate some of these bears. One of the first things I like to do, and this is just a small baby step, is I like to convert the angles from radians to degrees if I can. So this is the sine of 60 multiplied by the cosine of 45. And unfortunately, I don't like to use the M word memorize, but when it comes to these exact values, that would be very, very beneficial if we could memorize those values that are up there in the table. So the sine of 60 is going to be radical 3 over 2. Cosine of 45 makes radical 2 over 2. And when I multiply, I get radical 6 over 4. Okay, this cube sign is really, really tricky. And I want you to lock in here. I'm going to rewrite this first as the secant of pi over 3 cubed. So it's like saying, and that pi over 3 is just 60. So it's like saying, okay, let's do the secant of 60 times the secant of 60 times the secant of 60. And now if we know that the cosine of 60 is equal to 1/2, we're just going to reciprocate that to get a 2. So 2 times 2 times 2 makes a really nice 8. All right. Feel free to hit pause, catch your breath here at any point because we're cruising pretty good. So first things first, I'm just going to rewrite everything in terms of degrees, converting all these angles. So this is really the tangent of 180 plus the cotangent of 60 times the cosine of 45. All right, tangent of 180 is going to be 0. I'm going to think tangent of 60 first. The tangent of 60 is radical 3. So once I reciprocate that, that's going to be radical 3 over 3. And then the cosine of 45 is radical 2 over 2. So by the time I multiply these two bears, I'm going to get radical 6 over 6. Adding 0 keeps it the same. How about that? Whew. All right. Let's see. I do have a squared sign here. So I'm going to do cosecant of 60 times cosecant of 60. Just going to repeat it. Plus the cosine of 270. Okay. For cosecant of 60, I'm thinking, what's the sine of 60, huh? What's the sine of 60? Well, that's radical 3 over 2. So I got to reciprocate it. And you know what? I'm not even going to worry about rationalizing it because you may anticipate by the time I multiply these two fractions together, the radical is going to be gone anyway. Now, the most important thing I want to drive home here is remember 270 is a quadrantal angle, right? So picture the x-coordinate on the unit circle, and you can even draw your own unit circle if you want and say, what's the x-coordinate right here? I think it's a 0, right? Okay, so just multiply these two bears, you'll get 4 over radical 9, which makes 4/3. And that's your final answer right there. Wow. So you got a lot to think about, but hopefully, more than just memorizing, we got a small glimpse of where those values came from. They all originated from reading those special triangles and identifying those ratios. And that's where all those answers came from. Once we memorize them, we're going to be able to crush some problems just like these.